we're facing a bit of a double whammy, aren't we? On one hand, we've got this ever-growing mountain of waste, farm scraps, food leftovers, all sorts.
Yeah, huge amounts.
And on the other, there's this really urgent need to find cleaner, greener ways to power everything. It's a real puzzle. How do you tackle both at once?
Exactly.
So today we're doing a deep dive into a UK company that's not just thinking about it, they're actually, well, building something, a real solution.
We're looking at Wild Hydrogen. They're based down in Gloucestershire, and their approach is genuinely innovative, I think.
How so?
Well, they're looking at what we normally just chuck out all that biogenic waste and seeing it completely differently, not as rubbish, but, as a starting point.
A resource.
A powerful resource for clean energy, yeah.
And other valuable stuff, too.
Okay. And we've got some pretty detailed information here looking at their tech, their plans, their ambitions, really.
So think of this as like your fast track to understanding what wild hydrogen is all about,
Yeah.
and crucially, why it might be such a big deal. Not just for the UK, but maybe, globally.
Right. So our mission for you today, listeners, is pretty straightforward. Get your head around how Wild Hydrogen plans to do this almost magic trick of turning waste into carbon-negative energy.
Carbon-negative, okay.
And other useful things. It's about understanding if this could be, a real game changer for a sustainable future. Okay, let's dive in.
Let's do it. So first up, just the scale of the problem. We're talking massive amounts of waste, right?
Colossal. Just picture it. Fields of agricultural residues, overflowing food waste bins.
Yeah.
It's not just ugly. Managing it has serious environmental costs, economic costs, too.
Landfills leaking, transport, greenhouse gases.
It adds up.
It really does. And this is exactly where Wild Hydrogen, based in Hardwicke, Gloucestershire, sees an opportunity.
Yeah.
They're basically saying, hang on, this waste, that's our raw material.
Right, flipping the script.
Exactly, reframing the whole challenge.
Yeah.
And the key to this, the heart of it, is their tech. It's called the Rising Pressure Reformer, or RiPR. Sounds quite advanced.
It does, doesn't it, RiPR? But the tech itself is really geared towards solving these very practical, real-world problems.
Okay.
It's designed to be a cost-effective way to take all that varied waste we mentioned and turn it into hydrogen that's, well, aiming for carbon negative. Plus those other useful outputs.
So how does the RiPR actually do that? What's the science? It involves something called Supercritical Water Gasification, SCWG. Bit of a mouthful.
It is, yeah, SCWG. But the basic idea is quite neat, actually. Imagine taking that wet biogenic stuff, soggy veg peelings, damp straw, that kind of thing.
Right, wet stuff.
And hitting it with really high temperatures, over 374 degrees Celsius, way above boiling, and immense pressure, over 200 times normal atmospheric pressure.
Wow, okay, that's intense. So what happens to the water under those conditions?
Oh, this is where it gets really interesting. The water goes supercritical, meaning it's not quite liquid, not quite gas. It's got properties of both. And in this state, it becomes this incredibly effective solvent.
Okay.
It just rapidly breaks down the complex organic molecules in the waste, turns them into much simpler gases.
So the water basically goes into overdrive and just dismantles the waste. Molecular level stuff.
Pretty much. And the really clever bit here is the efficiency, traditional gasification.
Right.
It often struggles with wet feedstocks. You need these big, energy-hungry drying steps first.
Right, I see.
SCWG, because it uses water in this state, it just skips that whole drying stage. Processes wet waste directly. That's a huge energy saving.
That makes a lot of sense. Okay, so the RiPR uses SCWG, handles lots of different wet waste. Our notes mentioned agricultural residues, food waste, essentially even some plastics. Seaweed?
Yeah, the versatility is the big plus. It can handle a really wide range with minimal pretreatment, apparently.
And what comes at the other end? You mentioned outputs.
4 key commercial outputs they're targeting. First, the one everyone's talking about, clear hydrogen.
Clear hydrogen, okay.
High purity stuff. For industry, transport, maybe blending into the gas grid, lots of potential uses.
Right, the clean fuel buzz. Okay, number 2.
Biomethane, which is essentially renewable natural gas.
Okay, like replacement.
Pretty much. A big advantage there is it can often go straight into the existing gas pipes. That's really appealing for decarbonizing heating, things like that.
Makes sense. And then biochar. We've talked about that before, the soil stuff.
We have, yeah, that black carbon-rich material. Great for soil fertility, holds water, but crucially, it locks up carbon.
For a long time.
For a very long time, hundreds, maybe thousands of years. So adding it to soil sequesters carbon. That's a really big part of their carbon negative claim. Think of it like charcoal, but for soil health and carbon storage.
Got it. And the fourth one?
Captured carbon dioxide, co-euro itself.
So they're actually grabbing the co-euro produced, not just reducing emissions.
Exactly. That's vital. This captured co-euros can then be used maybe for making e-fuels or stored permanently, like underground in geological formations. That active capture is how they get to net removal of co-yo.
It really sounds like they've thought through the whole cycle. Our notes even say the tech is tunable.
Yeah, apparently they can adjust the process, prioritize different outputs depending on what feedstock they're using or what the market needs.
Flexible.
And another point, it uses widely available materials. No heavy reliance on, say, huge amounts of fresh water or those difficult-to-get rare earth metals you hear about with some green tech.
Okay.
Potential for off-grid operation, too, which could be big for remote locations.
Sounds incredibly promising. But how far along are they? Is this still just on paper or?
Good question. So wild hydrogen officially started in February 2022. But the seed of the idea was planted earlier. Their CTO, Mark Wickham, he had this vision for a simpler gasification process.
Comes from that background.
Yeah. Over 20 years in waste to energy. He was talking with James Milner, who's now the CEO, back in late 2021, and things really kicked off from there.
And they haven't just jumped straight to a massive plant, right? Yeah. Prototypes.
Correct. Smart move. They've built and tested 4 prototypes: Milli, Nano, Micro, and Mini. Cute names.
Yeah.
And that work got the tech to what's called Technology Readiness Level 6, TRL 6.
Which means?
Basically, it's been proven to work in a relevant environment beyond just the lab bench. So now the big focus is the next step, a 1 megawatt commercial demonstrator plant.
Okay, 1 MWO, where's that going?
Plan is Easington in Gloucestershire, just west of Stroud. They're aiming to commission it in 2027, finished by 2028.
And that's the crucial test, isn't it? Proving it works at scale economically.
Absolutely vital. Lab results are one thing, but making it work reliably, cost-effectively, day in, day out. That's what this demonstrator has to prove.
Big step. Needs funding, obviously. How are they managing that?
Well, they've done pretty well so far. Secured over £4 million to date. About £2 million of that came in this year, 2024. Okay. And right now, they're actively raising another £6 million, using a mix of crowdfunding and private investment, specifically for that 1 MW demonstrator.
Crowdfunding. Interesting. Shows they want public buy-in, maybe? That's not just money, is it? Partnerships must be key.
Oh, absolutely essential for this kind of venture. They're working with Wales and West Utilities, for example, looking at getting that biomethane and hydrogen into the gas grid.
Makes sense.
Early R&D involved Cranfield University, they're experts in SCWG, and an engineering firm, Helical Energy, especially under a government program, the Hydrogen BECCS Innovation Program.
BECCS.
Bioenergy with carbon capture and storage.
Got it.
Plus links with the National Composite Center and the Royal Agricultural University. So yeah, quite a multidisciplinary network.
Really pulling in different expertise. Okay, so behind the tech and the partnerships, the people, who's driving this? Yeah,
the core team seems like a good mix. Mark Wickham, the CTO and co-founder we mentioned, he's the technical brain, the visionary with that deep waste-to-energy experience. Then James Milner, CEO, also co-founder. He's focused on the business side, development, partnerships, growth strategy. There was a third co-founder early on, too.
And the team's growing.
Seems so. They've got a mechanical design engineer, Ralph, working on the CAD for the demonstrator plant, and a research chemist, Dr. Michael Sims, who joined last summer.
What's his role?
He's digging into the chemistry, analyzing the breakdown products, using things like GCMS, gas chromatography, mass spectrometry.
Okay, complex stuff.
Yeah, basically figuring out exactly what's happening in the reactor to optimize everything, get the best yields, the best quality outputs. That detailed analysis is critical.
No doubt. And the company structure.
They're a private limited company, got external investors. And that equity crowdfunding campaign earlier this year valued them at $16 million pre-money.
16 million. Wow. That shows some serious confidence.
It certainly suggests investors see significant potential.
Okay, so we've got the tech, the team, the funding, the partners. Let's boil it down. What really makes Wild Hydrogen stand out? What's their unique edge?
I think it comes down to a few key things that link together. First, that strong push for true carbon negativity.
Right, using bio-waste and capturing the co-rib.
Exactly, using biogenic carbon, which absorbs the Dakota while growing, and then actively capturing the CaRO from the process, plus making biochar. That whole package aiming for net removal. That's a powerful story right now.
Definitely. And the wet feedstock thing seems huge, too. Skipping the drying.
Huge efficiency gain, yeah. Simplifies the whole process, potentially lowers costs significantly, which leads to the third point, process simplicity and efficiency overall. Their goal is cost-competitive hydrogen, aiming for parity with gray hydrogen, the stuff made from fossil fuels, but without needing exotic catalysts or massive energy or water inputs. That would be massive.
Game-changing if they can hit that price point. And it's not just hydrogen. The circular economy angle.
Yes. Generating valuable stuff like biochar from what was waste, maximizing value, minimizing waste. That's textbook circular economy thinking. And finally, the design seems focused on scalability and flexibility. Could be big centralized plants, could be smaller units, maybe even off-grid. Adaptable.
Okay, so quick recap on the IPR tech itself. Input is wet biogenic waste.
Yep.
Core process is supercritical water gasification, that intense heat and pressure.
Right.
And the four main outputs are clear hydrogen, biomethane, biochar, and captured Kyoto, all potentially beneficial.
That's the core of it. And when you place that in the wider energy picture, they're really targeting high performance across the board.
Yeah.
Feedstock flexibility, carbon negativity, getting value from byproducts.
Areas where maybe other clean tech has limitations.
Potentially, yes. Of course, the big proof point is that 1MW demonstrator. Making it work economically at scale is the key challenge they need to overcome now.
Makes sense. And who buys this stuff? Who uses it? The market sounds potentially huge.
It really does. You've got heavy industry steel, cement, chemicals desperate to decarbonize.
Big emitters.
Exactly. Then sustainable transport trucks, buses, ships, maybe even aviation down the line that could use the hydrogen.
Okay.
Energy utilities, gas grid operators interested in the biomethane, maybe hydrogen blending.
Right.
The agricultural and food sectors themselves process their own waste on site, use the biochar.
Closing the loop there.
Yeah. And waste management firms looking for better options than landfill or incineration. It touches a lot of bases.
It really does. And it fits this wider trend, doesn't it? Waste to hydrogen. Our notes mention a UK scheme for turning plastic waste into hydrogen, too.
Yes, it's a growing field. While wild hydrogen is focused on biogenic waste, this idea of unlocking the energy and value in all sorts of waste is definitely gaining momentum.
Tackling waste and energy together.
It just makes so much sense, doesn't it? We have these twin challenges. Finding solutions that address both is critical.
So zooming out again, the bigger picture implications here. Net zero future stuff.
Well, wild hydrogen's work hits several really crucial points. Climate change, obviously aiming for carbon negative, moving away from fossils. Energy security, making clean fuel domestically. Sustainable agriculture through the biochar, and the circular economy turning waste into resources. It ticks a lot of boxes.
And for the UK's 2050 net zero target, this feels particularly important for those tricky sectors, right? The ones hard to just plug in and electrify.
Absolutely. We need renewables like wind and solar, no question, but for heavy industry, heavy transport, we need other solutions too.
Like clean hydrogen.
Clean hydrogen, biomethane from waste. These offer a pathway. And wild hydrogen's focus on wet waste tackles a specific practical problem. Plus, that biochar links industry decarbonization with better land use. It's quite integrated.
And potentially good for regional economies, too. New jobs, less reliance on imported fuel.
Definitely potential there. It feels like a holistic approach, which brings us back to that demonstrator plant.
The 1MW one in Easington.
Yes, that's the crucible, really. Getting real-world data, proving the concept works reliably and economically. That could unlock so much more investment and really accelerate this kind of SCWG technology in the UK and maybe elsewhere too.
Okay, so let's really nail down the key takeaways for you listening. Wild hydrogen. Primary goal is affordable, carbon negative, clear hydrogen.
And those other valuable outputs like biomethane and biochar.
Right. All from wet biogenic waste using the RiPR tech, supporting decarbonization and the circular economy.
And that carbon negativity comes from using biogenic feedstock, actively capturing cozier, and making that long-lasting biochar.
It can process a wide range of stuff: farm waste, food waste, compost, wood, potentially seaweed, some plastics.
Based in Hardwicke, Gloucestershire, big project is the 1MW demonstrator in Easington, aiming for 2027-2028.
And key partners include Cranfield University, Helical Energy, Wales and West Utilities, the National Composite Center, and the Royal Agricultural University.
A strong support network.
Definitely sounds like one to watch. So as we wrap up this deep dive, here's something to chew on. We usually see waste as just bad, a problem to get rid of.
The end of the line.
But what if tech like wild hydrogens lets us flip that entirely? What if our rubbish becomes a cornerstone of a carbon-negative future?
It really makes you think differently about the connections, doesn't it? Waste management, energy production, climate change, they're all tangled up.
They really are.
And if you want to dig deeper yourself, maybe look into how SCWG stacks up against other hydrogen methods' efficiency, environmental impacts.
Good point.
Or explore the economics and scale-up challenges for carbon-negative hydrogen tech like RiPR. It's not easy.
No.
Think about biochar's real long-term potential for carbon storage and soil health. How significant could it be? And finally, maybe check out UK government policy. How is it actually supporting hydrogen and carbon capture development? What funding is available? All fascinating areas to explore further.